This is Bob Capetta from the College of the Florida Keys, and this lesson is on rational exponents. So we know what 7 to the second power means. 7 to the second power means 7 times 7, which is 49. So what would 7 to the 1/2 mean? Well, let's keep in mind how rules of exponents work. If I have 7 to the 1/2 times 7 to the 1/2, that would have to be 7 to the 1/2 plus 1/2, which would be 7 to the 1, which would be 7. So 7 to the 1/2 times 7 to the 1/2 is 7. Also, the square root of 7 times the square root of 7 equals 7. So that's one way for us to see that 7 to the 1/2 power would have to equal the square root of 7. That's what it means. Similarly, if I had 5 to the 1/3 power times 5 to the 1/3 power times 5 to the 1/3 power, that would be 5 to the 1/3 plus 1/3 plus 1/3, which would be 5 to the 1, which would be 5. So something multiplied by itself 3 times equals 5. That's the same thing with cube root of 5. So cube root of 5 times cube root of 5 times cube root of 5 also equals 5. So if that's the case, we can see that 5 to the 1/3 would have to simply be the cube root of 5. So that's giving us an idea about how to think of these rational exponents. But if I have something like 8 to the 2/3 power, well, I can think of this as 8 to the 1/3 power to the second, again, using our rules of exponents. 8 to the 1/3 we've just established is the cube root of 8 to the second power. Cube root of 8 is 2. 2 times 2 times 2 is 8. So we get 2 to the second power, and my answer is 4. So we can see how these work. Let's take a look at a couple more. What if I had 9 to the 3/2 power? So this would mean 9 to the 1/2 power, all raised to the 3rd power. But what does 9 to the 1/2 power mean? That means the square root of 9 raised to the 3rd power. Square root of 9 is 3, since 3 times 3 is 9. 3 to the 3rd power is, of course, 3 times 3 times 3, which is 27. But we could also have negative exponents. We could have a situation like this, where I have 81 to the negative 1/2. So we need to think about what that means. That means 1 over 81 to the positive 1/2, which means 1 over the square root of 81. Square root of 81 is 9, which gives me 1 over 9. Or if I had 27 to the negative 2/3, what would that mean? That would be 1 over 27 to the 2/3 power. We need to think about what this means. 1 over 27 to the 1/3 raised to the 2nd power, which is 1 over the cube root of 27 raised to the 2nd power. 1 over 3 to the 2nd power, which is 1/9. So fractional exponents are nice tools for us to use, but we have to keep in mind that they still satisfy the rules of exponents that we've done before. Now, we can also use these things to do some simplification. So, for example, if I have the 6th root of x squared to the 4th. And for this video, let's assume all variables are positive. That makes things a little easier to work with. Just a quick note, remember that if you have the square root of a squared, it's actually the absolute value of a. But if a is positive, if a is greater than 0, absolute value of a equals a. If that's the case, the square root of a squared equals a. So for the sake of this video, we're going to assume that the variables are positive, just to avoid that circumstance. So what we have here is we have x squared y to the 4th to the 1/6 power. When we raise a power to a power, we multiply the exponents. So that would be x to the 2 times 1/6 times y to the 4 times 1/6, which would then be, right, 2 over 1 times 1 over 6, x to the 2/6, y to the 4/6. X to the 2/6 is x to the 1/3, y to the 4/6 is y to the 2/3. Which, depending on what the question is asking, may be the answer you want. But of course, you could also say x to the 1/3 is the cube root of x to the 1st, and y to the 2/3 is the cube root of y squared. You could write it that way. Or you could also write it this way: cube root of x times the cube root of y squared. Or you could write it as the cube root of xy squared. So there are many ways to write it. I think they're all equally good in terms of exponents, in terms of multiplication of two radicals, and then in terms of one single radical. Ways for us to write a problem like that. Let's take a look at another one. What if we have a situation like this? What if I have the cube root of x, y to the 4th, all raised to the 18th power? So we need to ask ourselves, what does this mean? Can we rewrite it in some sort of a meaningful way for us to analyze it? Well, it's xy to the 4th all raised to the 1/3 power, which is in turn all raised to the 18th power. So if I think of something to the 1/3 power and then raised to the 18th power, we multiply the exponents. 1/3 times 18. This would be xy to the 4th to the 1/3 times 18, which is xy to the 4th raised to the 6th power, which of course means xy to the 4th multiplied by itself 6 times. If you're not clear, xy to the 4th, 1, 2, 3, 4, 5, 6. How many x's do I have? X to the 6th. How many y's do I have? 4, 8, 12, 16, 20, 24. Of course, you could also use the rule that when you raise a power to a power, you multiply the exponents. X to the 1 times 6 is x to the 6th. Y to the 4 times 6 is y to the 24th. So that's a way for us to use the fractional exponents for us to go ahead and do some simplification. All right. Let's see what else we can do. If you have a situation like this, like the square root of 9 x squared y to the 8th. Again, important to recognize that we are saying that x and y are all positive numbers, so we don't need to concern ourselves with the absolute values. X and y are greater than 0 here. So what can I say about this problem? Well, what this is this is 9 x squared y to the 8th, all raised to the 1/2 power, which would then be 9 to the 1/2 times x squared to the 1/2 times y to the 8th to the 1/2. 9 to the 1/2 means the square root of y, square root of 9, excuse me. X to the 2 times 1/2, y to the 8 times 1/2. Square root of 9 is equal to 3. x to the 2 times 1/2 would be x to the first. Y to the 8 times 1/2 would be y to the fourth. So our result there would be 3xy to the fourth. So let's summarize our big ideas here in terms of our fractional exponents. What do they mean? If I have 10 to the 3/2 power, that means it is the square root, put a 2 there for emphasis, of 10 to the 3rd power, or if you like, the square root of 10 to the 3rd power. That's what it means. We could simplify it. I don't need to write the 2. The 2 is understood. Square root of 10 times 10 times 10. Square root of 10 times 10 is 10. Square root of 10. Similarly, if I have 9 to the 5/3, what does that mean? That means the cube root of 9 to the 5th, or it means the cube root of 9 to the 5th, which means the cube root of 9 times 9 times 9 times 9 times 9. We see it's a cube root though, so I need to look for triples. This would actually be more helpful for me if I would rewrite the 9s in terms of its prime factors of 3s. So let's rewrite this one more time as the cube root of 3 times 3, that's the first 9. 3 times 3 is the second 9. 3 times 3 is the third 9. 3 times 3 is the fourth 9. 3 times 3 is the fifth 9. It's a cube root, so I need to circle triples. Cube root of 3 times 3 times 3 is 3 times another cube root of 3 times 3 times 3, which is 3 times cube root of 3 times 3 times 3. And then I have a cube root of 3 that's left. So then my answer is 3 times 3 times 3, which is 27 times the cube root of 3. And that will conclude this lesson.